Alright, hey, welcome to class 4. This will be the Wednesday-Thursday class for week 2 of CSE 224. And today we're going to talk about Git. And Git is a source code control system, which means that if you're working on a large project and you're developing a number of source files, text files, that have, different pieces of your final project, it can help you coordinate a large number of files. Large in the sense of, if you had 10,000 files that went together to make your final project, how would you organize those? How would you share those among other people who were working on the project? And Git was created specifically when people were developing Linux, and there were huge numbers of developers working on the same code base towards this common goal, and they needed to be able to share code. They needed to be able to test changes to code without affecting other people who were using prior versions of that code, and so on. And so they developed a system called Git and made it freely available to the world. And it's arguably one of the most popular source code control systems in use. We'll use it this year. In our courses, you'll almost certainly use it at a university in your higher level classes. And the basic idea of Git is as follows. You have some sort of directory where you create a series of files, and there may be subdirectories that contain other files and perhaps other subdirectories. And you want to take all of this stuff and somehow do the following. One, save it somewhere so that if something happens, if one of these files or directories accidentally gets corrupted or deleted, you can pull back the saved version. So it's a way to do backups and archive. Two, you want to be able to undo changes. So maybe I think I'm going to improve my project by modifying this file, and I start making a bunch of changes in here, and that requires me to make some changes in these other files. And when I'm all done, I decide this was not a good idea. And all these other files are still intact, but I want to go back to earlier versions of certain files I changed. Git can help me track those changes and help me go back to earlier versions. It also lets me take this entire repository of files and directories and push it into the cloud where other developers can download it, and they can make their changes and push those up to the cloud, and I can pull down their changes. So we have sort of our local repository, what's called a repo. And then there's a cloud, which for us we're going to use GITLab.com, not GitHub, but GITLab. And we can push our local repository into a repo on GitLab, and somebody else can pull down from that repository and have their own version of a local repository, and it would have a dir, and it would have files underneath, and so on and so forth. And either user could make changes to files, push them up to the cloud, and then all the other users could pull those down and stay in sync with each other. And many times, especially for us in this course, these two users are both going to be us, right? This might be my directory on linux.engrcs.com. This might be the directory on my laptop at home. There might be another repo on my tablet that's sitting somewhere else, and I may want to keep all of those in sync. But for most of us, for this course at least, we're probably going to live like this, a local repository and a cloud. But this is still nice, right? It gives us a place to store our files off-site, and our Linux server is not backed up. There's no recovery plan if something goes wrong with that and the hard drive gets corrupted. That's it. Those files are gone. So you always want to be making your own backups, and using Git and a cloud server like GitLab is a really good way to make backups. GitLab is completely free. You have 10 gigabytes of storage per project, which is plenty for what we're going to be doing. And it's well established, it's well understood. and it's a good tool to have in your toolbox. And a well-crafted repository on GitLab is also something that you can expose publicly, put on your CV or resume, and when you go to an interview, you can point people to your GitLab repo, and they can look at your projects that you've put up there and see samples of your coding and so on. So we're going to work with Git today. And first we're going to work with this idea of a local repository, and then we'll go ahead and see how to put things in the cloud. There's a couple of other videos I've done in the past on this, and I'll link to those on Canvas. But this one you're watching right now is specifically for the current version of this class. So I'm going to work from my account on the Linux server, and I'm going to go into my new work directory, which we were playing with last time. And remember, I've got a few files in here. I've got a couple of subdirectories with some other files and so on, and I want to put all of this under Git control. So there's a few things you have to do. First of all, the very first time that you're going to use Git on a machine, you have to do some initial setup. You only have to do this once. If you're on a laptop, you do this once per laptop. If you get a new laptop, you'll have to do it again. I'm just starting up Git on my Linux account, so I'm going to have to do this once. And there's 4 configuration commands I'm going to have to do. The first is git config -- global.username. And then I'm going to put in my GitLab username. So you'd like to get an account on GitLab first to make sure that this username is available. But I've already got a GitLab account set up under the name nmacias, so I'm just going to use nmacias. And we can change this information later if we need to. So this is global space user.name. And then I'm going to do git config global user.email. And I'll put in an email address. And then git config global, and we're going to say initial.default branch main. So our main branch is going to be called main. And then I'm going to do one more git config global core.editor VI, and that's going to set up our default editor to be VI when we make what are called commit messages. So there's our initial configuration, and I only have to do that once. All right. So I'm going to go into this new work directory, and I want to put this directory under Git control. So here's the steps I want to do. First, I'm going to say git init, and it says initialize an empty repository. And at any time, I can say git status and see the state of my repository. If I say git status, it says I'm on branch main. I haven't committed any changes yet. I have some files that have not been added yet. So they're untracked files. So here's what this means. We have our set of files. And over here we have our repository. And in between, there's a staging area. So first we're going to put files into the staging area. We do that with git add. And then we can copy the staging area into the repository. We do that with git commit. And if all of this sounds kind of bizarre, that's okay. After you've done it a few thousand times, it starts to feel pretty natural. So I've got all of these files sitting here, and it says these are untracked files. Use git add file to include what will be committed. So I could say, git add main.c. All right, now if I say git status, it tells me changes to be committed main.c. So that's in the staging area, and it's waiting for me to commit it into the repository. And I have all these other files that have not been added to the staging area. So if I say git commit, it will bring up this file inside my editor, VI, and I should type a message here saying why I'm pushing this change into my repository. You have to type something here, so I'm just going to say initial check-in to show how to commit one file. There's a whole class you could take on just how to write good commit messages for Git. But in reality, most of us end up just, typing a period or something because we're in a rush. But these should be meaningful messages that explain the purpose of this change that you are committing. All right, so I'm doing my git commit. Now if I say git status, it tells me I'm on the main branch. I have these 5 files or directories that are untracked. Nothing added to commit. There's nothing to commit yet, but I do have untracked files. If I were to say git commit, it'll say, hey, there's nothing to commit. Now, if I want to put all of these files into the staging area, I can just be kind of lazy and say git add star. And if I do a git status, it says, hey, here's all the files you've got ready to be committed. And it goes into my subdirectories and it adds all the files from there. So I've got a number of files ready to commit. If I say git commit, I can add a message here. Full commit of the entire directory tree. And now if I say git status, I get the message I usually want to see. Nothing to commit, working tree clean. Now, nothing looks different here, right? I still have my files looking exactly like they were before. But let's say I come in here to main.c and let me make a real main program. Now if I do a git status, it notices that main.c has been modified, right? It's not staged for commit, but it is different from what's in the repository. So if I want to save that change, I could say git add main.c and then git commit. So I'll say this is a full working hello world program. And now if I say git status, my working tree is clean. Now I can also come in and I can say git log and it will show me a history of all the commits that I've made. So, and this goes backwards from bottom to top. So initial check-in to show how to commit one file was done at 1:36, and then full commit of the entire directory tree a minute later, and then a minute later full working hello world program. And that's basically it. Now the cool thing is, I don't notice any of this. This is all done using hidden files, so there's a hidden directory called .git. You do not want to go in there and mess with that. But that's where it's keeping track of all of these things that I've done. And if I needed to get back to, say, this version of my repository, I can do that by using this commit number. And I can roll back. We're generally not going to need to do that, but it's an option. Also, if I say find dot, I'm going to see something very different from before, because that's going to show me all of the files under this hidden .git directory, and you can see all these files that have been created to track these changes that I've been making. Those are all hidden from us normally if we just say ls, but again, we don't want to mess with this directory or any of these files. This is all internal stuff that Git's using to track our history. Alright, so let's move into the cloud, and some of this is going to be one-time setup. Some of it will be each time we start a new project, and some will be each time we want to make a change. Getting yourself an account on GITLab is a one-time step. You only have to do it once unless you decide you want to change your GITLab ID. So you're going to go to gitlab.com, and remember it's GITLab, not GitHub. And come over here and click on sign in, and it'll make sure you're a human. And then don't have an account yet, you can register here, or you can register through Google and so on. And it's the usual drill. It'll ask you for an email address and a password, and it'll send you a verification email and so on and so forth. Now, I've already set this up for myself, so I'm just going to go ahead and log in. And so my Git username is nmacias. Does not have to match your Linux username, but you can make this anything that isn't already taken. And then see if I can remember my password. Yes, I can. All right. So once you do that and you get logged in, you're sitting on a page that shows you your current projects. Now, the first time you do this, you obviously won't have any projects. I've got some projects that I've already saved. But that gets you a GITLab account. And in your configuration, right, when you did your git config user.name, the name that you put in there should be a name that matches your GITLab name. If it doesn't, you can change it. You can redo the git config -- global user.name and change the name if your name's not available. But make that match, and you can see all the things that we've set. So the username, email address, default branch, editor, and then these things were set up by default. So that's all we're going to do on here for now. The next thing we have to do is related to security. And what we need to do is set up a system so that my local machine, in this case my account on the Linux server, can talk to GITLab without needing a password and username to be typed each time. So we're going to set up what's called a public-private key pair. If you're taking CSE 215, we'll be talking about public-private keys in a few weeks. This is just something we're going to do. This is spelled out in the practice problems we'll be doing today. But let me run through this right now. So the first thing we're going to do is the command ssh-keygen -o-t rsa -b 4096-c, and then your email address. And then we're just going to hit enter once. It's going to ask us a question, and we're going to hit enter. It's going to ask us another question, hit enter, ask us again, hit enter. We're going to keep hitting enter 4 times until we get back to our prompt. And once we've done that, what's happened is it created a new directory for us. So if I look at my home directory, I don't see anything new, but if I do an ls-a, there's a new directory called .ssh. And if I go into .ssh, I'm going to see 2 files, idrsa and idrsa.pub. You probably won't see these known hosts and authorized keys files, but you'll see these 2 idrsa. So this is a pair of passwords. This password, the .pub, you're okay sharing that with the world. There's no harm in anybody seeing this public key. But this key, idrsa, that's your private key. That one you have to keep secret. So you keep that in this directory, but you don't show it to anybody. You don't share it with anyone. That's your secret password that only you know. But anybody who knows this public key can determine whether or not you know this private key. And this is how authentication is done on the internet. So by keeping this secret, but having access to it yourself, somebody else can use this and say, hey, are you who you say you are? And you can use this to generate a response, and the person asking the question can verify that you are who you say you are without learning this private key. So it's this public key that's the key to everything. No pun intended there. So here's what we're going to do. We're going to say cat idrsa.pub, and we get this big long string here. Now, depending on your terminal setup, you may need to right-click and say copy, or do Control-Shift-C or something like that. But I'm going to copy this to my clipboard, and then I'm going to go back to GITLab. I'm going to click on this little icon up here and come down to Preferences. And then down here I'm going to find SSH keys. And I'm going to say Add New Key, and I'm just going to paste that key that I copied. I'm going to leave the rest of the same, except I'm going to get rid of the expiration date so that it doesn't expire, and I'm going to say Add Key. Alright, at this point, I should be able to communicate with the GITLab server from my current account. So that's a one-time setup, right? That never has to change unless I try to do this from a different machine. If I have a new laptop and I want to set this up, I'm going to have to go through those same steps. So let's go back into our new work directory. Now this next step you have to perform once per repository, once per project. Ideally, each of your projects is going to be a separate repository, or maybe each of your classes will be a separate repository. But at some point, you'll have different repos that you're working with, and you need to do this step once per repo. So this you have to type carefully. Git remote add origin git at gitlab.com : your GITLab username, not your Linux username unless they're the same, slash, and then the name that you want the repository to have on GITLab. So I'm going to call this sample repo, and then it ends with .git. And then you're going to say git push origin main. And there you go. So it does some stuff, it tells you some information, and this worked successfully, supposedly. So now if I go back to GITLab and just click on my home symbol, hey, guess what? I have a sample repo, which I just created, right? Updated just now. And if I click on that, there's my whole directory structure. And if I click on, for example, main.c, there's my main program. All right, so now we've got a development cycle that can be very efficient for us. So for example, I want to make a change to my main program. Instead of saying hi, I want to say hello world for real. All right, how do I save that change? Git add main.c, git commit, and I'll say I just changed the message, git push origin main. All right, 3 commands: git add, git commit, git push. And now if I go over here and I look at main.c, it's got my new message in it. Let's do that again. Let's print out this message 5 times. Git add, git commit, git push origin main. Done. Come back here, let's take a look at main.c. It's got my new code in it. So this is pretty rapid once you get used to typing the keystrokes, right? Git add, git commit, git push. Git add, git commit, git push. If I change a different file, go ahead and make the change, git add, git commit, git push. It's the same thing over and over and over again. If I move into a subdirectory and I change a file, git add, git commit, git push. I could change, 10 files, git add all of them, or just git add star, git commit, git push. And so this is taking my local repository and constantly pushing it over each time I say git push to this saved repository on gitlab.com. Now the cool thing is, I'm looking at main.c, I can click on history and I can see all the previous versions. So if I want to go back to the full working Hello World program, I can say, let's browse that file. And there's what my file looked like at that point. If I want to go back to the very first version of main.c, I can browse that, and that was when I had just typed in some random characters. Right? So all this information is saved for me. And that's nice. Now, we're not going to talk about how we roll back to different versions and so on, but as a stopgap, if something goes wrong, if I corrupted my file, I could always come in here, I could look at the latest version of the file that was good, right? And I can just copy and paste it, right? I could copy this, I can say copy file contents, and then I can come over here and I can say vi new main.c, and in this case I can just right click paste, and there we go. And I just saved, hours of work that I might have lost otherwise. All right, so that's how we can push things into GitLab. Now, if I decide to make a new project, so let's make I don't know, let's call this homework 17. And let me call this, my code.c. All right, so I'm in this new directory. I've got new code that I've written, and I want to make a new GitLab repository. So what do? Git init, git add star, git commit. I'm just going to use a dot for a check-in message, right? And that's it. I'm under Git control now. If I try to say git push origin main, it's going to complain, right? So what do I have to do? I have to do that git remote add origin git at gitlab.com, and let me give it a name, homework17.git. And while I was typing this, I looked away and my cat came and walked across the keyboard, and I got all this extra stuff in here. And I typed a colon instead of a slash and all kinds of stuff. So when I say git push origin main, I'm going to get an error, right? It's going to say the namespace you were looking for could not be found. Okay, I go back and it's like, oh yeah, I made some typos. So I'm going to do it like this. Well, if I try to do that, it's going to complain. It's going to say, you already did an add origin. So to undo the mistake that I made, I need to do the following. Git remote remove origin. And then I can go back and remote add origin. And then I can git push origin main, make sure that works. Go over to GitLab, check your list of repositories, and there's my homework 17 repository with its one file, which is my code.c, which isn't actually code. All right, the last thing I want to show you is how we can clone a directory. So suppose that suppose I get rid of my homework 17. So I'm missing my homework 17 repository. It's not on my local system, but I know it's on GitLab. I can pull it back by saying git clone. So git clone git at gitlab.com and Macias / homework17.git. And now I've got a homework 17 directory, and if I look at it, there's my code. And if I say git log, it's still got a log file of when I first created this and committed it into the repository, and so on and so forth. All right, so that's a really, really brief kind of 20,000-foot view of Git. But that's probably all we're going to need to do with it. Now, in the practice problems, you'll get a chance to work with these commands and these ideas, and we'll also look at some other things like what can go wrong and how we can correct things when they go wrong. And we'll also talk about how we can use this public-private key pair that we just set up to do passwordless login. So that, for example, I can log into my account on the Linux server under nmacias without having to type a password. It'll automatically log me in. And remember, if I set up a symbol test, which is a shorthand for nmacias at, I can just say SSH $test, and it logs me in. That's a whole lot quicker than typing in nmasias at Linux blah 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 and then having to type a password and deal with typos in the password and so on and so forth. So we'll see some practice problems that'll get you through the steps for doing that kind of automatic authentication. All right, thank you.